Okay, here's May 2013, question 6. It's called Sum Triangles. It's really all about algebra. So the figure shows a filled out sum triangle. In a sum triangle, the numbers in each circle have to be equal to the sum of the numbers in the two nearest squares. Mikhail wants to fill out the sum triangle on the answer sheet, which we'll look at in a minute. He may only use whole positive numbers. Explain why it can't be a 2 in the yellow square on the answer sheet. So there's the answer sheet. The answer sheet had 2 of these on, one for this bit of the question to show why it wasn't 2, and then one for the next bit of the question where you fill it out with what it should be. So let's think about what happens if there is a 2 there. Well, if there's a 2 there, then the yellow plus the pink have to add up to 5. So it has to be a 3 to make them add up to 5. Then the pink and the green have to add up to 10, so it has to be a 7 to make the pink and the green add up to 10. But then we get a 2 and a 7, which don't add up to 11, because 2 plus 7 is 9. So 2 plus 7 is 9, not 11. So we need to explain that in words. So I've put 6.1 explanation. If the yellow square is 2, then the pink square has to be 3 because 2 plus 3 makes 5. Then the green square has to be 7 because 3 plus 7 equals 10. But 7 plus 2 makes 9, not 11. So the yellow square can't be 2. And then I've written, also have a look at the answer sheet, and then hopefully you'll have filled this in, and then maybe with a little comment like I've done. The next part is to fill in the numbers that do make it work. Now there is only one set of numbers that does that, and that's those. It doesn't take you that long to try different things out and see if you can make it work. So you try out a 1 in the yellow box, and then you get different numbers and you find it doesn't work. You've already tried it out with a 2, and then you try it with 3, and it does work. So it doesn't take you that long to get there, but there is only one correct solution. Then it says, Mikhail looks at the sum triangle at the top of this page, which I've put underneath on this, and observes that the sum of the numbers in the 3 circles is twice as much as the sum of the numbers in the 3 squares. Write a calculation that shows that Mikhail is right in his observation. So the sum of the circles is 12 plus 16 plus 8, which is 36. The sum of the squares is 2 plus 6 plus 10, which is 18. And then as a comment, I've put he's right because 18 times 2 is 36. Then the next part of the question is the same thing, but it's more abstract, and you're doing the same thing with algebra. So this is the kind of question that makes the difference between a 10 and a 12, really, once it starts to get this abstract. So show that, essentially this question is asking you to show that this is always true for any numbers that happen to work in this. So you've got the squares that are a, b, and c. Then this circle here is a plus b, the sum of the 2 nearest squares. This one is a plus c because the squares are a and c. And then this one is b plus c because of the b and the c. Use the variables a, b, and c and prove that Mikhail is right. So the sum of the circles, it's a plus b plus a plus c plus b plus c. So if you write that down, you can see there's 2 a's, 2 b's, and 2 c's. So that's 2a plus 2b plus 2c. Now if you try and write down 2 times the sum of the squares, so that's 2 times a plus b plus c, as I've written here. Now 2 times a plus b plus c, if you want to multiply that bracket out, then it's 2 times everything in the bracket. So 2 times a, 2 times b, 2 times c, and you get the same thing, 2a plus 2b plus 2c. So you can show with algebra that you get the same things for the sum of the circle and 2 times the sum of the squares. And then a comment, Mikhail is right. So there's my neat answers, and the marks you could have got for them were 4, 4, 4, 4.